So this is the sample data given, and today we are trying to find temperature at 10 a.m. So there are three ways of to finding it, and the first one is linear interpolation. Linear interpolation requires 2 points. So how do you choose the 2 points? So 10 a.m. is here, right? So you have to choose the 2 points beside it. So that would be 9 a.m. and 11 a.m. So this will be your fx0, and this will be your fx1. So this is the general formula. And so I'll teach you how to solve this. F bracket x1 and x1. So basically you sub the values in. So fx1 is 71, fx0 is 57, and so on and so forth. So the final answer is 7. So the second interpolation method is quadratic interpolation, which requires 3 points. So how do you choose the 3 points? So 10 a.m. is here, and you choose the 2 points beside it. So how do you choose the other point, the third point? So 12 a.m. minus the 10 a.m. here. 12 minus 10 is 2, and 10 a.m. minus 7 a.m. is 3. So we choose the one with the small difference, which is 12 a.m. So in this case, this will be your fx2. So you get your 3 points, located your 3 points, then sub into the general formula, and you get your answer. The third method is Newton's interpolation, which requires more than 3 points. So in this case, we will take 4 points, which means all 4 points will be chosen. Okay. So all 4 points will be chosen. So in this case, this will be a fx0, fx1, fx2, fx3. So sub all the points in, and you get your Newton's interpolation.
Yeah, how I said just now, we're trying to find the interpolation data during for 10 a.m. using linear, quadratic, and Newton's interpolation. Let's just jump right into it. Okay, you see all these complicated things? We've already done it. Done all the questions already. So first thing first, type in this command, clear all CLC, which basically forces MatLab to clear everything you've done before and try to start a new M file. Okay, F basically is to print the data, print the question 1 in the final answer in this, because usually we can't find anything. You can't type anything here and nothing will come out. Okay, it's like this. Question 1, then question 1. Simple. Okay, then this is the data that we've been collecting. Small t, big T. As you can imagine, small t refers to the time. Okay, and the big T refers to temperature in Fahrenheit. We don't usually use degrees Celsius because it doesn't need us to. Okay, see this? These are all data. See the highlighted areas. See all these like T1 become highlighted, which is basically just imagine it as X and Y, like unknowns. And these are all the values. Small t1 is equals to this. Big T1 equals to this. Incidentally, everything is the same. T1 2, this it become is 9, then T3 is 11, 12. Okay, it's the same as temperature. Ignore the green ones. The green one is just for your perusal. And this is the first method, linear interpolation, and this is the formula for using it. Do you know what's this? I assume that you know because you guys are taking MatLab. So this is the product of A1 and this bracket, which is the same as the formula that Jiahao told you just now, that shown you, not told. Okay, and this is the over. This is divide. Okay, T2 minus T1 over T2 small T2 minus T1, which is here. It's all here. Okay, which is basically telling you MatLab to use the values from before and substitute into the equation to find the answer here, which is the answer should be here. At 10 a.m. temperature is 64 Fahrenheit. Okay, moving on. F(f), because see final answer is by using this method is the same. See the resemblance, and the final answer is here. This and this are the same. Okay. Second method, quadratic interpolation. This is the formula. Product. Okay. And this is the formula that we translated from written form into MATLAB form. Take a good look at this. Why do we use B1 and B1, B2 and A1, A0, and A2? Because we are trying to use a new unknown to use another unknown, so we can substitute the value inside, so the MATLAB knows. Because MATLAB is just a program, and the program can be programmed by humans. Okay, F(f) is still the same thing. That is all from me. Okay.
So let me introduce the third method. Third method we use is Newton interpolating polynomial. So what is the difference between this method with the previous method is that this method can use as much as reference point, and then the reference point must more than 3. So in this case we choose 4 points, mean all of this data. So we go back to see the general form of this method. So this is the general form, and then this general form has been introduced by my groupmate, so I didn't talk so much about this. And then this is the equation for in this case. So what is the in this equation? C0, C1, C2, C3 actually is the coefficient. Coefficient can determine by this graph, this table. So and then we need to type all of this into the MATLAB function. But due to the time limiting, so we have already done the MATLAB coding for this case. So this is the coding for this case, and then we try run it first. Okay, so the answer has been shown like this way. When by using temperature 1, the temperature is 64. By using method 2, temperature is 65. By using method 3, temperature is 64.3. So how to show the answer by so much detail? We can use the f'f function. F'f function means he will show the answer in the work. So the num2 str temperature 2 actually is show the answer inside this function. And then this coding is about to make, after we type this coding, so the line will automatically go to the second line. You want the line will not continuous. So for example, we delete this coding, we run it again. So we have the coding, the line will keep going. So this kind of answer will make us confusing, so not so very nice for this one. So we copy back this coding, then run it again. So this is the answer, should be shown like this way. So now we have find all of this temperature, we need to discuss our finding. So how to discuss? The best way to discuss our finding is plotting a graph. So enable to easily to analysis. So we need to plotting 3 methods in the one graph. So when we plot a graph, we need the data. So first is we need to insert the interpolating data into the raw data. So this is the first method. We insert the time 1. Time 1 is 10 o'clock. Temperature 1 is the answer for the method 1. So same with the method 2. Time 1, 10 o'clock, temperature 2, and then the method 3 also same like this way. And then we need to plot the graph. So we need to plotting 3 lines into a graph. So we just write, then this is the x-axis, y-axis, x-axis, y-axis, and then we need to differentiate the line. So the name of the line also. So first is we differentiate by using the different color. So for first method we use red color. Second method we use K. K in the MATLAB coding mean is black color. So third method we use blue color. And then this is the name of the each method. Each line represented each line. And then the title, X label, Y label. And then we run it. So this is the graph. This is how the graph look like. So we can see from the graph the blue wait let me the red color here is for method 1, the blue color is for method 3, black color is for method 2. So how to discuss our finding? So now linear interpolating has assumed as the true value. So we need to find the error between this method with the linear interpolating method. So from the graph, so first we enlarge first. So from the graph, the error between two methods, the line of the two methods is less. So mean that the error is less also. So from this graph, we can see that the red color line and the blue color line has the less error between two lines. So mean that the blue color is the method 3. Method 3, the value of the method 3 is closest to the value of the method 1. So mean the method 3 Newton interpolating polynomial is appreciated to use.